So I prepared this set of slides, Introduction to Machine Learning, which is, I'm going to run this down pretty quick. Basically, I'll just use one very simple algorithm called k-nearest neighbors as an example to demonstrate to you what machine learning is and to get started. So basically, in this quick 30-minute session, I try to control it to 30 minutes, but might overrun a little bit. I'll just quickly introduce to you what is machine learning, what is an algorithm, and what is the algorithm k-nearest neighbors, what is the bias-variance tradeoff, and probably also cross-validation, depending on if we have time. So what is machine learning? So basically, as the words show here, so machine learning, right? So machine is basically learning from human beings. So what are they learn and where are they learning all the knowledge? So basically, they're learning some patterns, and the way they learn is through the data. So basically, I have this graph showing here the process of basic machine learning process. You always start with data, and here you also have an algorithm. So basically, the algorithm just learn from the data, and you get a model. And with that model, you make some prediction based on new data. So actually quite straightforward. It's just like how people or human beings learn day to day. So for example, you might think, for example, we have this weather forecast, let's say, and so basically we as laymen, we're not professional like weather forecasters, but we all can somehow predict the weather based on what we have seen before. So for example, we've seen some clouds, some dark clouds coming, and we kind of predict, okay, it's gonna rain. So basically the clouds, they're like the data, and we basically our brain is basically the algorithm there, and we see, okay, the dark clouds means that it's gonna rain in a couple minutes, for example. So that is the model, so a built model there. And then when there's a new data, so let's say today at 3 p.m., there's some new dark clouds forming up in the sky, and then that's the new data, and we make the prediction that's okay at the maybe 3:15, it's gonna rain. So this is basically a very simple process, and I worded here as, computers learn from the data to create models that can make predictions without explicitly being programmed. So what does that mean? So basically, computers always, like, you can think about those programming process as the traditional programming. Basically, it's just, okay, a dark cloud equals to, for example, raining. And here we learn because sometimes, for example, we learn from, okay, how dark, for example, some clouds maybe they overshape, but it doesn't lead to rain, so it can happen, right? So based on experience and your and later, for example, you have newer like weather forecasting technology that you can make better forecast, and that's how the machine learning gets improved and improved. So, so nothing is being explicitly being programmed here. So that's the key. Okay, so if no questions, I will move on to basically the tasks. So what machine learning can be used to help us to do different tasks. So here I present to you, so basically some very simple tasks that machine learning can help us to accomplish. So we have classification and regression. So on the left-hand side, this classification, so we have different dots, and each dot can be seen as, the different colors are the outcomes, and the X and Y are their input values. So those are the input data. You can think of the dark clouds as either X or Y, something like that. And then the dots, the color, maybe the green, the lighter green means it's, for example, it's raining. And then the light blue means the turquoise color, it means it's not gonna rain. So let's say, so that's some very simple example or how you can understand the graph. And then the dark curve here, so that means that is actually the machine learning model, or what we call the classifier here. So it basically helps us to classify. So based on some input, we classify the weather as either raining or not raining. So that's just simply put what we're trying to do here. And then regression is another thing. So basically here you can understand it as it's not the weather it's not the rain or not rain. It can be, for example, the temperature. So basically we based on something, for example, the humidity or basically like different, for example, the sunlight hours, let's say. So some different input data, and you try to predict the temperature, which is I call it numerical, or some people may say it as continuous. So basically, those are not a black or white. So it's not two or three or four categories. It is a continuous value. So this is called regression. And today since we have limited time, we'll just focus on classification tasks, and which is I would say the simplest and the most intuitive. And you would try to get a intuitive sense of what a supervised machine learning model is. So by supervised I mean we have an outcome here. So we have something we try to predict. Instead of, like, let's say, compared to unsupervised machine learning, it is some tasks that we do not have an outcome. So let's say we just a very classical example here is you try to separate people into groups. So we don't know like what the groups are or what features each group has. It is just some arbitrary groups, but we just accomplish the task of separating people into groups. So that's it. So that we are not gonna cover today, but you're just feel free to explore by yourself. But I believe Professor Miklos also mentioned it's a very important concept that you should have keep in mind that whenever people talk about machine learning, you might think, okay, whether it's supervised or unsupervised. So this will give you a intuitive sense of what the people are trying to do. So here is basically another quick demonstration of what I mean by classification and regression. So again, I'm going to use weather prediction. So we have temperature as the regression, so which I already explained. So based on some input data to predict the weather for which is the temperature here. And then for classification, it's gonna be whether it's hot or cold. So basically, even for temperature, you can make it into a classification task. Sorry about that. So you can make it into a classification task, which is by separating the temperature into two baskets, two baskets, like hot and cold. So you have a boundary in between. So above, let's say 60, it's hot, and below 60, it's cold. So here's a quick summary. So we have quickly introduced the machine learning models to you, and the machine learning tasks that those models can help us achieve. And now we have this so-called k-nearest neighbor algorithm. And this is one of the algorithm that can help us make predictions. So basically, here I use very visual example here to demonstrate what this algorithm is trying to achieve. And later we'll see the real codes together. And so basically we have this first step called initialization. So basically we just collect some data, and here the data are all in 2 dimensions. So they're in this flat dimension. We in the real life it tends to be more than 2. So it can be 3-dimensional or even more. So for each data point we can have different ways to observe it. So this is how you understand it. So here we have class 1, class 2, and class 3. And for this given point, we try to classify it into class 1 or class 2, or class 1, class 2, or class 3. So it's going to be one of them. And then we try to calculate the distance between the given point and the rest of the points. So for each of the rest of points, so we calculate the distance. So this is, I believe, back to the high school math. So it's we try to calculate the length of the connecting line between each of the pairs. And then here we use the so-called Euclidean for now. And then this is actually the most widely used way of calculating the distance. So I believe intuitively it makes sense, right? So we want to categorize one point to the groups, and we definitely want let's say the closest to the group. So we want, let's say, this dot to D1, D2, and D3 and D4. And let's say what we can do is probably make an average. So that's one way. So any other ways you can think of? Anyone want to give a shot? After we get the distance, the next step is to sort the distance, and then we just sort them from short to the shortest to the longest. And then as you remember, so the D4 seems to be the closest, so it's ranked the first here, and D1 the second, and so on. And then it's a classification. So basically we have this K as the number of neighbors, the neighbors, so-called neighbors you want to keep. So here we have K equal to 7. So we want to keep the first 7. And then we count the dot color. Each dot here count as 1 volt. So here we have 3 yellow ones and 4 gray color. So we have 3 volts for the yellow and 4 for the gray color, and then 0 for the orange color. And obviously here we have 4 as the winner. And then we choose 4 as, when we go back, we choose 4. Basically the 4 gray color as the winner. So we have the gray color as the categorized, we put the point into this basket. So this is basically how the algorithm works. Is an intuitive way, but at the back end, you might feel it's a little complicated, but no worries. So and I think this one we can just get another intuitive sense. So how does the K, so how does the number of points that we use to cast the votes have an influence on the outcome? So here we have smaller K and the large K. So if with the K is small, it's gonna be a low bias and high variance. So here it means, so for basically for the bias is you always categorize it correctly to the true label. So you never misclassify any points, any dots here. So that is why we call it low bias. But a high variance here means the curve is really like, it's really hard to describe using any simple mathematical function. And basically that simplicity is you can understand as the variance or the level of noise, the noisiness here. So if a high variance means it's very noisy. So this classifier is just, it gets influenced by sometimes, for example, we have one yellow dot, one like the yellow color here, it's gonna be a big curve here. So which doesn't really make sense compared to this straight line, which will basically give you more intuition and more like easier to adopt here in a model. So this is a quick summary of the steps, and just keep that in mind. And later we will, not later, actually, right now we will start show this in action, and which I will just quickly go to a Google Colab, which we have learned together last time, I believe. And